In this video, we are going to talk about the mean value theorem, that is MVT. And to talk about MVT, you have to know these things. That when you talk about MVT, then you have to know that we are talking about a continuous function and also a differentiable function. A continuous function and also a differentiable function. So when we talk about a continuous function, these are some of the examples of a continuous function. So we have a linear function which is f of s is equal to 2s plus 1, and also a polynomial function which is f of s is equal to s squared plus 3s plus 1, and an exponential function f of s is equal to 2 exponent x, and also a logarithmic function f of s is equal to log x, trigonometric function f of s is equal to sin x, and a rational function f of s is equal to 1 over x, and an absolute function f of s is equal to an absolute of x. So these are some of the examples of a continuous function. So when you see these functions anywhere, then you have to realize that these functions are continuous. And also when you talk about a differentiable function, when you realize all these examples of continuous function, this linear function 2s plus 1, when you realize when you differentiate the 2s plus 1 with respect to x, it will be 2. And also when you differentiate this polynomial s squared plus 3s plus 1, it will give you 2x plus 3, to give you 2x plus 3. And also when you differentiate this exponential function 2 exponent x, so when you differentiate this, you will subtract minus from here, so it will be x 2s minus 1. So meaning an exponential function can also be differentiated. And also a trigonometric function, a logarithmic function, when you differentiate a logarithmic function with respect to s, it will be equal to 1 over x. And when you differentiate a logarithmic function with respect to x, so this is sine x, when you differentiate sine x, you get cos x. And when you differentiate cos x, you get minus sine x. And when you differentiate this rational function, so let's say s exponent minus 1, so it will be minus 1 s exponent minus 2, which will give you minus 1 over s squared. So meaning a rational function can also be differentiated, and also an absolute function. So for an absolute function, f of s will be equal to minus x and also x. So when you differentiate it, you get minus 1 and then 1. So all these are examples of a continuous function and also a differentiable function. So when we talk about an MVT, so let's say a point AB under the function f. So under the realm of MVT, we say this function f must be continuous and also differentiable on this point. This function must be continuous and differentiable on this point. So when you realize these two things, then you have to realize that there exists a constant c between these points. There exists a constant c between these points. So when you check about the number line, this is the c. So the c is between these points. So when you realize that, then the formula of MVT will tell you that the f prime of the constant c will be equal to f of b minus f of a all over b minus a. So let's try an example of this MVT. So when f of x is equal to s squared plus 2x under the point 1 comma minus 1, then also, so we say f prime of x. So we say f prime of x must be equal to f prime of c. F prime of x must be equal to f prime of c. So then if f prime of c is equal to f prime of x, so if f prime of c is equal to f prime of x, then we can say we can differentiate the function f of x with respect to x. So when you differentiate the function with respect to x, when you differentiate the function with respect to x, you will get 2x plus 2. 2x plus 2. Then also f of b, we find the value for f of b and also f of a. So you have to realize that b on the point is equal to -1, and b on the point, a on the point, is equal to 1. So you code the function again. F of x is equal to x squared plus 2x. But then f of 1 is equal to 1 squared plus 1, which will be equal to 3. And also f of -1 will be equal to -1 all square plus 2 minus 1, which will be equal to, this one will give you 1. So 1 minus 2, which will give you -1. But then we say that f of 1 is equal to 3 and f of -1 is equal to -1. So then by the formula of MVT, so since f prime of x is equal to 2x plus 2, then also f of b, that is f of -1, is equal to -1, then also f of a is equal to, then f of a is equal to 3 divided by b minus a, and you know that b is equal to -1 and a is equal to 1, which will give you -4 or -2, which will give you 2. So then we say that 2x plus 2 will give you 2. So 2x will be equal to 2 minus 2, which is equal to 0. Then x will be equal to 0. So hence we say c is equal to 0. Then there exists the number c between a and b, which is equal to 0. So between a and b, it is only 0 that is between 1 and -1. So between the point 1 and -1, it is only 0, c is equal to 0, that is between these numbers. So a, b, and here is -1, and here is 1. So the c here is equal to 0. So this is the idea of MVT. So let's go to the next video about the increasing and decreasing of a function.